Wire temperature ratings indicate the maximum safe operating temperature for a wire, specified in degrees Celsius by the insulation material. Wire size, measured in American wire gauge or AWG, determines the wire's thickness, with lower AWG numbers signifying thicker wires. Current capacity is the maximum current a wire can safely handle without overheating. Wire temperature charts correlate wire sizes with their current carrying capacities at different temperatures, guiding electricians in selecting the appropriate wire for a given circuit. THHW, or thermoplastic high heat resistant wire, is rated for 90 degrees Celsius and commonly used in residential and commercial installations. THHN, or thermoplastic high heat resistant nylon, also has a 90 degrees Celsius rating, but features a nylon outer sheath for enhanced abrasion and oil resistance. Examining the wire temperature chart for THHW at 75 degrees Celsius and 90 degrees Celsius reveals that an 8 AWG wire rated at 75 degrees Celsius can carry 50 amps, while the same 8 AWG wire rated at 90 degrees Celsius can carry 55 amps. This increase is due to the high temperature rating allowing the wire to handle more current without overheating. Several considerations influence a wire's current carrying capacity. Firstly, ambient temperature plays a crucial role. Higher ambient temperatures reduce the wire's ability to dissipate heat, thus lowering its current capacity. Secondly, bundling multiple wires together can lead to heat buildup, requiring a reduction in current capacity to prevent overheating. Thirdly, installing wires in conduit restricts airflow, further reducing the current carrying capacity. Consulting the National Electrical Code, specifically Table 310.15 B16, provides detailed ampacity tables based on wire type, temperature rating, and installation conditions. Remember that these charts and ratings are essential for ensuring safe and reliable electrical installations. Wire temperature ratings determine the maximum safe operating temperature of the wire. The rating is typically indicated in degrees Celsius and is specified by the wire's insulation material. Wire size is measured in American wire gauge, with a lower AWG number indicating a thicker wire. Current capacity is the maximum amount of current a wire can safely carry without overheating. Wire temperature charts provide the current carrying capacity of wires for different operating temperatures. They are typically used by electricians to select the appropriate wire size for a given circuit. THHW, or thermoplastic high heat resistant wire, is a type of wire with a temperature rating of 90 degrees Celsius. It is commonly used in residential and commercial electrical installations. THHN, or thermoplastic high heat resistant nylon, is another type of wire with a temperature rating of 90 degrees Celsius. It is similar to THHW but has a nylon outer sheath that provides better resistance to abrasion and oil. The wire temperature chart for THHW 75 degrees Celsius and 90 degrees Celsius shows the following. Firstly, for AWG 8 wire with a temperature rating of 75 degrees Celsius, the current carrying capacity is 50 amps. Secondly, for AWG 8 wire with a temperature rating of 90 degrees Celsius, the current carrying capacity increases to 55 amps. This is because the high temperature rating allows the wire to carry more current without overheating. The current carrying capacity of a wire also depends on the ambient temperature. Higher ambient temperatures reduce the current capacity of the wire. If multiple wires are bundled together, the current carrying capacity is reduced due to heat buildup. When wires are installed in conduit, the current carrying capacity is further reduced due to restricted airflow. When selecting wire, it's important to consider not only the temperature rating and ampacity but also the specific application and environment in which the wire will be used. For instance, in high-temperature environments, a wire with a higher temperature rating, such as THHN or THHW, is necessary. Similarly, in damp or corrosive environments, a wire with appropriate moisture and chemical resistance should be selected. The National Electrical Code or NEC provides comprehensive guidelines for selecting and installing wires, including ampacity tables and rating factors for various conditions. Consulting the NEC and other relevant resources is essential to ensure safe and compliant electrical installations. Furthermore, understanding the different types of wire insulation is crucial. Common insulation types include thermoplastic, thermoset, and rubber. Thermoplastic insulation, such as polyvinyl chloride or PVC, is widely used due to its low cost and good electrical properties. Thermoset insulation, such as cross-linked polyethylene or XLPE, offers superior heat and chemical resistance. Rubber insulation, such as ethylene propylene rubber or EPR, provides excellent flexibility and moisture resistance. The choice of insulation depends on the specific application and the environmental conditions. When working with electrical wiring, it's also important to follow safe work practices. Always disconnect the power before working on any electrical circuit. Use appropriate personal protective equipment or PPE, such as gloves and safety glasses. Inspect wires and connections for damage before energizing a circuit. Never overload a circuit or use undersized wires. By following these guidelines and understanding the principles of wire temperature ratings, ampacity, and insulation, you can ensure safe and reliable electrical installations. Remember to consult the NEC and other relevant resources for specific requirements and recommendations. In addition to temperature ratings and ampacity, other factors can affect the performance and lifespan of electrical wires. These include voltage drop, insulation resistance, and mechanical strength. Voltage drop refers to the decrease in voltage along the length of a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Insulation resistance is a measure of the insulation's ability to prevent current leakage. Low insulation resistance can indicate damaged or deteriorated insulation, which can lead to electrical shock or fire hazards. Mechanical strength refers to the wire's ability to withstand physical stress and strain. Wires used in harsh environments or subject to frequent movement should have adequate mechanical strength to prevent damage. When selecting wires, it's important to consider these factors in addition to temperature ratings and ampacity. The NEC provides guidelines for calculating voltage drop and determining minimum insulation resistance values. It also specifies requirements for the mechanical protection of wires in certain applications. Proper installation and maintenance of electrical wiring are essential to ensure its long-term performance and safety. Wires should be installed in accordance with the NEC and manufacturer's instructions. Connections should be made using approved methods and materials. Wires should be protected from physical damage and exposure to harsh environments. Regular inspections should be performed to identify and correct any problems such as loose connections, damaged insulation, or excessive voltage drop. By following these best practices, you can extend the lifespan of your electrical wiring and minimize the risk of electrical hazards. Finally, it's important to stay up to date on the latest developments in electrical wiring technology. New materials, designs, and installation methods are constantly being introduced. Staying informed about these advances can help you improve the efficiency, reliability, and safety of your electrical systems. Trade publications, industry conferences, and online resources can provide valuable information on new electrical wiring technologies. By continuously learning and adapting, you can ensure that your electrical skills and knowledge remain current and relevant. Let's delve deeper into the practical aspects of wire selection and installation. When determining the appropriate wire size for a specific application, consider the following steps. Firstly, calculate the load current. This involves determining the total amount of current that the circuit will be expected to carry. Secondly, determine the ambient temperature. This is the temperature of the surrounding environment where the wire will be installed. Thirdly, apply any necessary diluting factors. These factors account for the effects of ambient temperature, bundling, and conduit on the wire's ampacity. Fourthly, consult the NEC ampacity tables. These tables provide the allowable ampacities for different wire sizes and insulation types under various conditions. Fifthly, select the wire size that meets or exceeds the calculated ampacity. It's always better to err on the side of caution and choose a slightly larger wire size than is strictly necessary. When installing wires, follow these guidelines. Firstly, use appropriate tools and equipment. This includes wire strippers, crimpers, and conduit benders. Secondly, properly support and secure the wires. This prevents them from sagging or becoming damaged. Thirdly, make secure and reliable connections. Use approved connectors and techniques to ensure that connections are tight and free from corrosion. Fourthly, protect the wires from physical damage. Use conduit, raceways, or other protective measures to shield the wires from impact, abrasion, and other hazards. Fifthly, label the wires in the circuits. This makes it easy to identify and troubleshoot problems in the future. By following these practical tips and guidelines, you can ensure that your wire selection and installation are safe, efficient, and compliant with industry standards. Remember to always consult the NEC and other relevant resources for specific requirements and recommendations. Always adhere to the most current edition of the NEC, as codes and standards may change over time. Be sure to check with local and state authorities for local amendments to the NEC that may apply to the wiring job location.